Hey guys, so in this example we want to have a look at how to work out the surface area of a pyramid. So the surface area of a pyramid is a little bit more complex than we might expect. So if we're going to take this pyramid here, we can flatten it out, and when we're concerned with the surface area, we're looking at the area that this covers in a two-dimensional space. So if we were to flatten it out completely, how much space is that going to cover? So what we want to do is we want to say take our pyramid, which we know has this square base. It's a square base pyramid, and that's not a perfect square, but hey, it's a good attempt. And then it's got these four different sides, right? So it's got one triangle up here, then it's got one triangle up here, one here, and one here. And if we were to kind of fold all of these sides into the center, then you would get this pyramid which we have here. So we know that the length of the sides here are going to be 6 meters and 6 meters. And we're also given the height of the pyramid. So it says that the height of the pyramid from here to here is going to be 4 meters. So that kind of doesn't really help us that much, because on our shape here, we know to work out the surface area, we need to know the length and width of this square, or the shape we have on the base, which we have. And then in order to work out the area of a triangle, we need to have some base distance, which we have, but we also need a height. So we don't really have the height. But if we look over at this pyramid here, it's kind of saying, well, we know the height of the pyramid here, but once we've folded the shape flat, what we're interested in is the height which would run along this side here. So we're interested in the height of the triangle there, not the height of the triangle here. So if you can see, I've kind of drawn another triangle here, and that's going to be a right-angled triangle. So we know there's a height of 4, and we know that this distance here along the base is going to be some distance as well. So we can kind of redraw this red triangle. I'm going to redraw it down here, and we're going to have, say, I'll try to draw that a little bit better. We're going to have this red triangle here, and then the sloping green side, which is what we're interested in finding. And we know that's going to be right-angled. So the height of this side is 4 meters, and the length of this bit here, if you can see, that's going to be the center of our pyramid. So the length from here to here is going to be half of this side length. So this side on the bottom here is going to be half of 6 meters, so it's going to be a 3 meter side length. So what we're looking at now is we're looking at a right-angled triangle where we know two sides, but we don't know the hypotenuse. So this should be jogging some memories, and we should be able to use Pythagoras, or Pythagoras Theorem, to solve for this side. So Pythagoras Theorem just says c squared, or the length of this side here, squared, is equal to the length of the other two sides squared. So c squared is equal to 4 squared plus 3 squared. So c squared is going to be equal to 16 plus 9. So you can say c squared is equal to 25, which is 16 plus 9. We're not interested in c squared, we're interested in the side length, which is c. So we must take the square root of both sides. So we take the square root of that, the square root of that, and it says that c is equal to 5. So we can see that the height of this side here, or this sloping side which I've drawn here, is going to be 5 meters. So if we take that over onto our diagram, what it means is the length of this height here is going to be 5 meters, and that's going to be 5 meters in every single triangle. 5 meters there, 5 meters there, and then 5 meters there. So that kind of looks a little bit like something more which we can solve. So we now have this area here of a square, and we've got a base and we've got a height. So we can essentially just break this down into two different pieces. So we've got these 4 triangles, which are going to be one of the piece, and then we've got this thing in the center. So if we want to work out the area of this square base in the center here, so if we want to work out the area of this square base thing in the center here, we know that the formula for finding the area of a square is just going to be, how many units do we have down this side, how many do we have across this side? We just multiply one by the other. So we have length times width, so 6 meters times by 6 meters. So the area of this shape in the middle is going to be 6 meters times 6 meters, or 36 meters times meters, meters squared. Important with our units. And then we want to work out the area of one of these triangles. So I'll draw a separate triangle down here. So if we've got a triangle, and we know that it has a base width of 6 meters, and it has a height, which we worked out over here using our Pythagoras, of 5 meters. So height of 5 meters and a width of 6 meters. So with our triangles, we know that we can kind of take one portion of the triangle, say this portion here, and we can kind of fold this over, and we can put that over here. So we can effectively fold our triangle in half, so that we end up with what is just a rectangle. So rather than having a width of 6 meters like it did before, it will now have a width of 3 meters and a height of 5 meters. So you can say it's 3 meters by 5 meters, which is 15 meters squared. 3 by 5 is 15, meter by meter is meter squared. Or alternatively, what we can just do is we can say, well, we know the area of a triangle is given by this formula that it's the base, the width of the base times the height divided by 2. So we could just say, well, the base is 6, the height is going to be 5. If we divide this whole thing by 2, 6 times 5 divided by 2, 15 meters squared. It's up to you how you work it out, but that there is the logic behind it. So now we know we have 15 meters squared per triangle. So if we want to work this out, well, we've got one triangle up the top, 15 meters squared, and we're going to have 4 of these. So we have 1, 2, 3, 4 of these triangles, which are 15 meters squared. So you have 4 times by 15 meters squared in triangles, plus 36 meters squared in our square base. So the total area of this shape is going to be equal to 4 times by 15 meters squared for each of the triangles, which is just going to be 4 times 15 is 60 meters squared, plus 36 meters squared. It's just going to be equal to 60 plus 36 meters squared. So 60 plus 36 is going to be 96 meters squared. So that's how we work out the surface area of a pyramid. It's actually quite tricky if we don't know the height of this side here, the height of the sloping side, and you might need to use some Pythagoras to actually work out some side lengths in this triangle so you can work out the surface area. I'll put out some examples for you guys to have a go at. Thank you, and I'll see you for the next video.